All right, in the second part here, we are going to talk about this idea of arc length. Okay, so let me remind you of what we talked about, what I mentioned earlier. So we have two ways to describe arcs. We have arcs in terms of angles. So of the 360 degrees, my example picture shows that the degree measure halfway around is 180. Now the length of AB is saying how much of the total circumference is the arc I want. Okay, so we are going to use the degree measure, the measure of the arc, as almost like a fractional piece of the whole circumference. Okay, so let me show you two ways to look at this, because sometimes we need to have this proportion set up to help us figure out the piece we're missing. Okay, arc length. In a circle, the ratio of the length of the arc to the circumference is equal to the ratio of the measure of 360. So I want you to see here that length goes with circumference. Oops, let me get a different color here. And then the measure goes with degrees. Okay, so when we say length, we're not talking about the degrees. So I've got arc length over pi r squared. So remember, that's just circumference. So a portion of the length of the circumference is equal to the degree measure out of 360 degrees. Now, I do not use this part of the formula. You may use that part of the formula if you want. I choose not to, just because I feel like it's an extra step you need to remember. So let's just kind of go back to this first proportion. Okay, so let's set number one up. Find the length of arc AB. All right, so I am going to do right here, the arc length. I don't know the arc length. Let's just call that X, okay? Now, the denominator is the circumference, okay? So the circumference, I don't know, but I can calculate. So I'm going to go ahead and plug that formula in. 2 times pi. Now, I do know the radius is 5, okay? So I have a X divided by the circumference equals, everything over here is degree measures. So out of 360 degrees, what's the degree measure of the arc? So when I see this central angle here, I know that this is 150 degrees. Now, that is not the length of the arc. That is the portion of the degree measure of the arc. So I'm going to cross multiply here. Okay, I'm going to go ahead and cross multiply. So when I do x times 360, I get 360x. Now the other side, I'm simply going to do 2 times 5 times 150, and then just keep pi on the end of it. So 2 times 5 times 150 is 1500. Now, you can certainly multiply into pi. I'm going to wait till the very end because I don't want to round too much of it. Okay, now I'm ready to solve for x. All right, so since it's being multiplied by 360, I'm going to divide everything by 360. So now what I'm going to do is take, my calculator has 1500 in it. I'm going to hit times pi and hit equals, and then divided by 360. And then now I'm going to maybe round to the nearest tenth. So x is equal to 13, it's 0.0899, so I'm going to call that 13.1. Now this is length, and I see a unit of meters, so I'm going to go ahead and put meters on there as my unit. Okay, so basically what I see here is the fractional portion that 150 is out of 360 is the same fractional portion that my arc length is out of the whole circumference. And so when I set it up as a ratio and cross multiply, that allows me to isolate the section I want. Okay, so let me go back over to my picture here. So the length from A to B is 13.1 meters. It's also 150 degrees. So arcs can be degrees or lengths. Okay, so one more thing I want to add here. When it says measure of an arc, that's equal to a degree. When it has the word length in front of it, I'm just going to say here that's equal to a unit. I mean, it could be meters, inches, centimeters, but when you see the M, that's your degree measure for measure of. All right, let's do one more and I'll have you guys try the last two. Okay, find the length of AB here. So I'm going to do proportion. So on the left, I want the length of AB, that's going to be my x, over the whole circumference. And so the circumference, I don't even need the letter C. I'm going to do 2 times pi times the radius. So on the right-hand side, I want degrees. So since I see a central angle of 90, I know that this is 90 over 360. Okay, let's cross multiply. So I'm going to have 360x. So I'm going to do 2 times 15 times 90, which is 2,700. And then just keep the pi with it for just one more step. So when I solve for x, I'm going to divide by 360. So on the left, it cancels out to 1. So now I'm going to do 2,700 times pi, hit equal, and then divide by 360, and then I will round. So x is about 23. Again, I'll just do tenth all the way through here. 23.6, and my unit of measure here I see is feet. So I'm going to add that in there. Okay, I would like you to try 2 and 3. Okay, so I'd like you to pause and then come on back to the video. Okay, I'm getting 4.2, approximately 4.2 on the first one. All right, I need to find, I'm doing AB here, so I'm going to outline. This is the arc I want. Okay, so I've got x over 2 times pi. Now my radius is not 34, that's showing my diameter. So I'm going to use 17. And then the red arc is connecting to the 150, so that one is fine. Okay, 360x is equal to, so 2 times 17 times 150, 5,100 pi, and then divide by 360. All right. So rounded to the nearest tenth again, I'm getting approximately 44.5, and it looks like it is centimeters. All right, so all 3 of them were working a very similar procedure. We are taking a portion of the circumference to get the arc length. Now, I want to go back to number 1 because I want you to see, okay, if we are simply doing arc length, like what we're doing here, can you see this is a quarter of the circle, okay? Can you see that? 90, actually let me come back to the formula, 90 out of 360, if you do 90 divided by 360, you get 0.25 or a quarter. So I'm basically taking a quarter of the total circumference. Okay, so let me go back and do the 2 times pi times 15. So if I do 30 times pi, I get like 94.25, but that's going to be all the way around. I want to know what a quarter of the way around is. So if I multiply that by 0.25, I get my answer of 23.6. Okay, so when we know the piece of the degrees of the 360, we could apply that to get the arc. All right, now we're going to look at some more complicated ones where we don't always find arc length. Sometimes I want you to find the degree measure or the circumference. So I really am going to encourage you, unless you have a really strong handle on what we're doing now, I want to encourage you to use this same formula, and then we're just going to find other missing pieces. Okay, let's look at the next few. Okay, so this time the directions say to find the circumference of circle Q. All right, so here's how I want you to think of this setup again. I want you to think of, I'm going to write here arc length over circumference is equal to, I'm going to put here the degree over 360. Okay, so I've got length over circumference, the degree we're given on 360. So here's what I'm going to look at. This number right here is sitting next to this arc. Okay, so this is the arc length of arc ACB. So I'm going to go ahead and substitute that in here, 81.64 over C. Now, I'm going to go ahead and do something over 360. This degree measure has to correspond to this arc length. So because the 260 is over here on the other side of the Q, I know that this arc length is also 260. Okay, if I were given the other side, the other angle right here, this arc, I couldn't use it to go with the 81.64. I'd have to calculate that amount. So because I want circumference here, I can simply leave C in my formula and consider that my variable and just cross multiply. So I've got 260 times C equals, so 81.64 times 360, and I'm not going to round this, 390.4. And then now I'm ready to solve for C. So divide by 260. So I get circumference is equal to, I guess I won't round this because it's exactly 113.04. So that would be, the unit is inches. So you need to start to consider the formula. Arc length over total circumference, partial degrees over 360. So everything on this side is a degree measure. Everything on this side is like inches, meters, that type of thing. Okay, I want you guys to try the last three. At least try to get things set up before you come back to the video and see how far you can get on that. Okay, I think I'm going to start with answer because that way you can check it and move on if you're fine. So the measure of arc AB is 119.9 degrees. For number 7. Number 8, the radius is equal to 2 feet. And for number 9, the circumference, you might have rounded this a little bit different. You might have said 75.4, that's fine. Okay, but let me go back and set these up here. Okay, I want this arc. So I'm going to have the arc length over total circumference. So I don't know the circumference, I'm going to have to calculate it. So 2 times pi times 9. Now I want a degree amount. So I don't know that amount. That's your x. Okay, that's what you're trying to figure out. So let's cross multiply. So I'm going to do 9 times 2. I'm going to leave this as 18 pi times x. 360 times 18.84 is 6,782.4. And then here's what I'm going to do. I'm going to divide by both 18 and pi. And when I do it on my calculator, I'm going to leave it in parentheses just like I wrote out here. Okay, so 18 divided by 18 is 1, pi divided by pi. So I'm going to take the 6,782.4 divided by parenthesis, 18 pi close parenthesis, and I get about, there's the 119.9. Okay, so check that last step. If you've got everything I have but still missed it, check that last step with parentheses. Okay, number 8. So I need arc length, which is in terms of feet here. So 1.57 over total circumference, which I need the radius. So it's going to be a formula, 2 times pi times r. So I need degrees over here. So 45 does match this length. So 45 over 360. Okay, cross multiply here. So on the 2 pi r, I'm going to do 2 times 45, which is 90. So I'm going to write that as 90 pi times r.
Please come to the main office.
All right. Sorry about the announcements. Just ignore those for right now.
Jada Hawkins.
Okay, I'm going to keep working.
Elizabeth Shiner.
So 565.2. And then
Logan
90 pi,
Hobson.
90 pi.
Southern.
All right, parentheses, don't forget about that. Okay.
Gavin Winborn.
Gosh, I'm sorry about these announcements, but I'm really close to being done with the video.
Jonathan
Divide,
Crispin.
divide.
Please come to the main office.
Okay, so you are left with radius on the left. So I'm going to do the 565.2 divided by, open your parentheses, 90 times pi, close your parentheses, and there it's like 1.998. So I rounded that up to 2 for the answer. Okay, last one. Let me separate out what we've got here. All right, so you should get about 75.37. So I have a ratio of arc length over total circumference. So arc length is right here, 41.87. Now I want C, so I'm just gonna put the letter C in there, not 2 pi r, because I don't need the r, I just need the whole circumference. All right, I know I need something out of 360. So the 200 is on the same side as the arc length, so that's the number I can plug in. So let's just cross multiply. 200C is equal to 41.87 times 360. Looks like, oops, let me fix that, make that look a little nicer. 15,073.2. Now you can divide by the 200. And I wrote it rounded to the nearest hundredth. If you rounded to the nearest tenth, it would be 0.4, but still centimeters. Okay, so those last 3 examples are ideas of not just finding arc length, but another section of this proportion. Okay, if you